I have to cover Dick. I'm covering Dick in the second hour.
All right, so our last couple, they're just little properties. They're not necessarily a rule like the big three we were doing. But I wanted to stick with what we had been using to discover our other rules. We've been expanding out a lot, and I want to stick with expanding out so we continue to refresh on what the heck exponents mean. Okay, the two things we're going to look at today is having an exponent of 0 and an exponent that is negative. We saw some negative ones on our sheet yesterday, and we're like, Miss Kelly, what is this? We're going to talk about those today. I wanted you to see them yesterday, so when we looked at them today, it wasn't like a brand new, they can be negative. I didn't know that kind of thing. So let's take a look at our first one. It says, part 1, defining x to the 0. As usual, we start with our table. It says expanded form. So I'm going to expand out the top. 5 times 5 times 5. So I'm going to expand out the top. So in your first row right now, you should have a 5 times 5 times 5. And then we have that fraction bar. And we have another 5 times 5 times 5. At the very top of the sheet, just that first row.
It's got a little bit of feel.
What's going to happen with those 5s when we simplify? What's going to happen? What's going to happen, Sam?
Probably multiply.
They are all being multiplied right now, but what's going to happen when we simplify? This pair of 5 simplifies, right? Simplifies. Simplifies. Careful.
You have 1. No.
You have 1. Remember, when we did this with our division property, with our quotient property, I was very careful to say that they simplify, not cancel. Canceling means I end up with a 0. Simplifying means I end up with a 1. 5 divided by 5 is 1. 5 divided by 5 is 1, not 0. So if I simplify that out, I end up with a 1. Now that third column says simplify using our exponent property. We just quizzed on this yesterday. We reviewed it the last couple days. What do I do with the exponents when I'm dividing? Do I add, do I subtract, or do I multiply? What do we do when we're dividing? What do we think? Where could we look if we're not sure? Oh, there we go. Yeah, we've got one graphic organizer out. What do we do with them, Sam?
Won't subtract.
You subtract your exponents. So, if I do 3 minus 3, what do I get? 0. 5 to the 0, which equals?
0.
It equals 1. We just did all the expanding and simplifying. So I can't get 0 for one answer and get 1 for the other. Anything to the 0 power, we have to be very careful. Go ahead and try out those next 2 rows. Expand them out. Do your exponent property. So we just refreshed on what it means to expand and simplify. And we just refreshed on that our property says we're going to subtract exponents. I'm going to even make a little note up here for you. Subtract exponents. So try out those next 2 rows. We'll talk about them. And we will come up with our rule, what we do if there's a 0 exponent. Check out that second row because it's looking great. The second row is looking great. Oh, let me switch back to my purple here. There we go. So there should be, we expand out, we have those 5 x's on the top, and we have 5 on the bottom. Simplify, 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 simplify. Now, a few people as I walked around had an X in the simplified box And some people had a 1. Excuse me. Some people had a 0. So let's think about this. Do I have any x's left?
No.
No. Some people had an x there. I don't have any x's left. They all simplified. Again, they simplified. They didn't cancel. So I'm not left with 0. I'm left with 1. I know 5 divided by 5 is easier for us to see as 1. X divided by x is also 1. If I take the same thing and divide by itself, my result's 1. Whether it's a number or a variable, it doesn't matter. If we subtract, we have x, we have 5 minus 5, which is x to the 0, which we just saw. It simplifies down to 1. So now let's do the same thing for the third row. Don't let the y bother you. Expand out all your x's, expand out all your y's. Don't let those bother you. Expand them all out. Let's see what we have left. Go ahead and try that third row. All right, so let's take a look. Everybody's working on their expanding part. So I'm going to go ahead and expand. A couple of people are finishing their simplifying. So don't let it bother you that there's x's and y's. That's okay. There can be x's and y's. We've done questions like this before.
I got 2 more rows and $200.
We can expand that out.
Hey, Jim, I need to go do plus.
All right, so we have all of our x's and y's all expanded out. Now, when we go to simplify, x's can only simplify with x's and y's can only simplify with y's. So I can't just simplify an x and a y because while on those first two, we just started crossing everything out. X's can only simplify with x's. So all 3 x's are going to simplify. And then your y's can only simplify with y's. So what do I have left? How many y's do I have left? 2. So we have y to the second.
What about the 1?
Now, all the x's do simplify like Miss Kylie, so the x's just disappeared. We can put a 1 there if we'd like. We don't have any x's left, but it doesn't become a 0. Remember, guys, mathematicians get lazy. They don't always write the 1. If you write the 1, I'm totally cool with that. If you just put y squared, that's okay too, because that's really all we had left.
Wait, what's the 1 in front of it?
For the x's. The 1 in front are from the x's. Some people wrote a 1, some didn't. If you didn't, that's okay. Now, for our exponent property, we're going to subtract. So we have 3 minus 3 for the x's, and the y's have 4 minus 2. So 3 minus 3 gives me 0. 4 minus 2 gives me 2. But now if we look at our simplified form, though, there aren't any x's left. So you have your choice. If you want to write the 1 there to represent what you have for the x's, you can. Or again, if you just want to put y squared, you can. The big takeaway, we did get some experience, a little bit of a refresher, expanding out, a little refresher on simplifying, another refresher on what we do with exponents when we divide, and now the big takeaway, any non-zero number represented by x, anything to the 0 power, guys, what does it equal?
1.
Equals 1. Now, I know you're thinking, Miss Golly, why didn't you just start today? Just tell us that and we'll roll with it. Or punch it in the calculator and we'll figure it out. Well, I can't put x to the 0 in my calculator. But I didn't want you guys to be like, why isn't it 0? I wanted to show you guys what it actually means.
What happens if you put x to the 0?
I don't want you to just believe, oh yeah, Miss Golly said anything to the 0 power is 1. Okay, I wonder why it's not 0. We got to see that today. We got to see why x to the 0 is 1. We got to see that. Our other property, and then we will take some time after this to fill in our graphic organizer so you have everything in one spot. We're going to use our expanding again, but now we're going to see what happens with those negative exponents. Okay, so go ahead, that top row. 5 times 5. I want to do this first one with you. I know based on what we just refreshed, everybody knows how to expand. And I think we're okay with the simplifying part. But how is this one different than anything else we've simplified so far? Why is this one different? What do you think, guys? What makes this one different? Where do I have more 5s at? On the bottom. Where are we used to having more at? We're used to having it on the top. It doesn't change. Those 5s can simplify. Those 5s can simplify. Now the 3 5s that are left, they can't magically float to the top. I can't do that. They're stuck. But what's left in the top though? Be very careful, it's not 0. What's left in the top? What's going to be left up there? A 1, yes. There's going to be a 1. How many 5s do I have on the bottom?
4, 5.
Careful. We got rid of 2 of them. 3. 5 to the 3rd. So a little bit different. We had more 5s on the bottom than the top. So when we simplified, it looked like our top ended up being empty, but there's really a 1 there. Now let's use our exponent properties, and let's see what happens. We just refreshed on this one. We said we subtract exponents. We saw this on our worksheet yesterday. It's top exponent minus bottom, no matter what it works out to be. So it has to be 2 minus 5. 5 to the negative 3rd. That happened on our worksheet yesterday. I said, hey, just leave it. It's okay. We're using our property. But now 5 to the negative 3rd, mathematicians are a little picky. They don't like negative exponents. We want to always have those positive exponents. So to make it positive, check it out. All we have to do is move that power to the bottom. And again, I didn't just want to show you that. We expanded it out and we saw what it should be simplified like. So to make that negative exponent positive, we just move it to the bottom. That's all we had to do, was move it to the bottom. Go ahead, guys, try out that second row. Try out that second row. Expand it out, simplify it. Let's see where our x's end up. So I said, guys, at least make sure that you can expand out. And we should be able to simplify. In your second row, we should at least have what I have up on the board. At least. For your second row, you should at least, everybody in this room can do what I have up on the board right now. I know everybody in this room can do what I have up on the board right now. Now, I understand it's new for us. If you're kind of nervous to take that next step, I get it. This is new for us. It looks like I have nothing left in the numerator. But I don't have a 0, I have a 1. I have 3 x's left. But they're in the bottom. I have an x to the third, guys, but it's in the bottom. I can't magically float those x's up to the top. I can't magically float those x's to the top. That's why I wanted to expand these out. I can't float them up to the top. So, now if I do my exponent property, I wanted to expand it out, guys, so you can see why we end up with stuff in that denominator, in the bottom piece. I can't have, this is the reason why we expand it out. Everything simplifies. My x to the third that's left, it's in the bottom. The x to the third I have left is in the bottom. Now, if I do exponent properties, we have to subtract. Top exponent minus bottom. So I have x to the negative third, but then we know from our simplifying that x to the third needs to be in the denominator, or the bottom. So it's kind of that flipping piece. So with that negative exponent, we just have to flip it, and it'll become positive. For the last row, if you didn't do it already, for the last row, try to fill out as much as you can. Everybody should at least be able to expand it out and simplify. If you're kind of shaky with using the property or what to do when you get a negative, that's okay, that's the new part. For that third row, everybody at least expand and simplify. We should be able to do that part. All right, I've got lots of people at different kind of comfort levels with this. But like I said, we should all be able to at least expand this out and simplify. Because to be honest, guys, when you get on your test, or whenever you're taking a test, quiz, if you have to deal with exponents, if you forget the property, you can always expand out. We've expanded out every one of these today, and we've come up with the right simplified form. And then we show how the exponent properties, we can get the same thing. So the expanding out piece, that's just a fallback. Takes a lot of time to expand those out. But it's something we could always use just as a fallback. So on the top, we have our 3 x's, and there's just 1 y. On the bottom, 2 x's, and 1, 2, 3, 4 y's. So when we simplify, 2 of the x's will go. And it doesn't matter which y you simplify. As I walked around, a lot of you simplified the y's that were right on top. 1 on top and 1 on the bottom. They're straight across from each other. So now I just have to look at what's left. What do I have left on the top? What do I have left, Sam?
Oh, scratch.
What's left on the top?
Oh, I just have this 1x and...
Yep, there's just 1 x. What do I have left on the bottom, guys? How many y's? 3 y's, yeah. We've got 3 y's. 1, 2, 3. We've got 3 y's left on the bottom.
Can they put anything else except the X on the top?
If you're going to put something else in the top with the x, there'd be a 1, if anything. You can put a 1 if you want. You don't need to, because we still have that x up there. So you can put the 1 if you want. You don't have to. Now, if we use the properties, we're going to have 3 minus 2 for the x. And we're going to have, remember that y, I did this example on purpose, that y really has a 1. 1 minus 4. So we have x to the first, y to the negative third. the y to the negative third moves down to become positive 3. The x stays put. So we only want to move things around that have negative exponents. I know it's a totally new idea for us. I get it. So if we have our little summary, here's the idea with negative exponents. If I have a negative exponent and it's not in the bottom of a fraction, it's just hanging out. If I want to make the exponent positive, I need to flip it and move it to the bottom. I need to flip it and move it to the bottom. Same thing we did up here with 5 to the negative third, we moved it to the bottom. X to the negative third, we moved it to the bottom. Y to the negative third, man, I really liked 3's on this one again. It's not even my favorite number. So y to the negative third moved also. Now the one we didn't see, and I couldn't make this one work with expanding out. If I have a negative exponent and it's in the bottom of a fraction, it's in the denominator. You do the opposite. You flip it. Whoops.
It was just an accident.
You flip it, and it's up in the top now. So if you want to make an exponent positive, you just need to flip where it's at in the fraction. If it's up top, flip it bottom. If it's bottom, flip it up top. Okay? The last thing I want to do today with this is I want you to take out your graphic organizer. Take out your graphic organizer. And then tomorrow we will next class.
Next Monday.
We will practice this. So go ahead, take out your graphic organizer. Take out your graphic organizer. Looks like this if you're not sure. I need to open up mine. It's the one thing I did forget to load.
It's just a little bit confused.
What do you think? Which one is it? This one or this one?
Maybe it's
So how
still
do we figure this out?
open.
This guy just told you. You have a negative exponent. What do you do? You flip it, right?
Okay. Maybe.
Put a 1 down, right? On top.
Mine doesn't want to open for some reason.
No. You already said. I don't know what.
It's like a likely that goes there.
So put a line. Put a line. Put a line. Now, this is on top, right? We need to put that on the bottom, correct? Or keep it on the top?
Probably.
Okay, so let's wrap up here. Our graphic organizer. Let's add some notes. All right, if we have, let's look at the negative exponent rule first. So negative exponent rule. If I have a negative exponent, where do I need to move it so it becomes positive? What did we just do? Where did we move it to? To the bottom, yeah. Oh, for some reason, mine doesn't want to take notes today. There we go. We move it to the bottom. Now we move it to the bottom, that exponent becomes positive. Don't let it bother you that we have an x for a base and an a for an exponent. It doesn't change the rule. We have x's and a's just so we make it generic. Just so it's generic applies for everything. So if we look at example 1, we're not expanding anything out. If we look at example 1, the negative 5, it has an exponent, guys. What is it? What's the negative 5's exponent? That's a 1. Yeah. So if we have a positive exponent, is that negative 5 going anywhere?
No.
No. But now x to the negative second, where does it need to go to become positive? Where does it go?
Bottom.
Bottom. Positive exponents, they're happy where they are. They're already positive. They're in a great mood. They're going to stay. Negative exponents, they're not happy. So they move. They move. Now with number 2 up there, we need to do a little simplifying first with our exponent rule. With the 4 and the 8, those aren't exponents. So I'm going to do what that fraction bar tells me to do. It says to divide. 4 divided by 8 simplifies to 1/2. I don't subtract the 4 and the 8. They're not exponents. But now the k's, though, the k's have the same base, so we're going to subtract the exponents. And I get a -3. We subtracted the exponents. We have a -3. Where do I need to move my k to make it happy? Where does it need to go, Colin? Colin's pointing down to the ground. You're right. It needs to move. The 1 stays. The 2 stays. Just the k moves. So now when we go to start our practice, have this out. You have the rule. You have 2 examples. Now the 0 exponent rule, I don't know if they come much easier, guys, than the 0 exponent rule. Anything to the 0 power is? 1. Now here's where we have to be careful and why I wanted to do a couple examples with this. If we look at example 1, what's the exponent on the 7, guys? The exponent on the 7 is a 1. Then we have x to the 0. So we have our 7's going to stay. The x to the 0 is 1. So we have to be careful when working with negative and 0 exponents. We can only apply the rules to what actually has the 0 exponent or the negative exponent. We can only apply those to those things. One last example for today. This one puts a couple properties together, and I want to keep showing you these. I do. I want to keep throwing in little pieces where we kind of take things to the next level. In the numerator, outside and inside exponents, we multiply. We saw that property. We refreshed a lot on that this week. When we're dividing, we subtract the exponents. And we get a 0. Anything to the 0 power is 1. So now when we go to start our practice, this sheet should be a resource for you. It has all of our properties on it. When we go to study for our test, this sheet, all your properties are in one nice place for you. You have 2 examples for each property. I know a lot of you on your quiz really use this sheet. You're able to match up what the question looked like on your quiz with one of the examples from your organizer. And that's what it's for. It's a resource. It's not just something, I got to fill out because Miss Golly said I have to. This is to help you. Now, all your properties that we've been working so hard on the last couple weeks are in one spot for you.